Problem 3330. Find the original type string 1. So to solve this problem, we need to know one concept, and that's sliding windows. And the idea of a sliding window is exactly as it sounds like. So let's say we have, it typically works for an array of numbers, but you can also do it for a string, right? It's like 1, 2, 2, 3, for example. You have a window of size 2, and you can slide that across the entire array. Now, the size of the windows can be dynamic. So basically, we can have here a length of 2, but after we slide it over by 1 unit, perhaps we increase that to size 3. That's the idea. Now, obviously, you can do this without sliding windows, but sliding windows would also work here, because this question just basically sees if the previous one is equal to the current one, so A, B, C, D. You just continuously check if the two adjacent values are equal. If they are equal, you just add the answer by 1. But for the sake of concept building, we're going to use sliding windows. So we're going to give you the example here. And the problem statement is that Alice basically held the key for at most one time. So how many possible outputs are there? Well, for the given example, she only pressed the key at most once. So there's case 1 where she didn't press it, consecutively, and case 2 where she pressed the key down, once. So for the case of there being no pressed keys, well, obviously that's just one outcome, which is the original string. She typed it as intended, but then she potentially made a mistake here for the second case. And what do you do with the second case? Well, for a given string, we need to find the occurring consecutive sequence. And after you find the occurring consecutive sequences, you find the length of it subtracted by 1 and add it together. So for what I mean by this is, this has a consecutive sequence, right? 2 B's, that's length 2, and this is length 4. So therefore, if this chunk were to be the part where she, pressed the key too often, then it's the only possible string she could have meant was A, B, C, 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 where you subtract 1 from the length of the consecutive. And the same goes for here, right? You subtract 1 to see that she could have meant 3 potential outcomes, where it's either A, B, B, C, 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 or A, B, B, C, C, or A, B, B, C, right? Because if she were to have pressed it, then this could have been, she could have pressed these intentionally, but then pressed this by mistake, or she could have pressed these intentionally, then pressed these by mistake, or she could have pressed this intentionally and then pressed these by mistake. So it's always subtract 1 from the length of the consecutive string to derive how many potential intended outcomes she could have had. So that's why you do this, and then you sum it up. So 1 plus 2 minus 1 plus 4 minus 1 gives you your answer, which is 1 plus 1 plus 3, which is 5. And you see where the sliding window comes in, right? Because let's say for the string here, we always have the start and the end pointers to be this, and then if they are not equal, then we shift both to the right by 1. So this is not equal, so now, right, this becomes the start and this becomes the end. This is equal, so let's do what? Let's shift this to the right one more time. But obviously this is incorrect. This is not the same as B. So we keep a pointer or a tracker L that counts the current length. So originally when it was equal, the length was 1. It's simply the end minus the start because it's not inclusive. And then once we moved it over, well, it's no longer equal. The length no longer gets updated, and we simply add that to a global variable m that keeps track of the total number of potential outcomes. So we add that to m, and we update s so that s is equal to the end, and then the end gets incremented up by 1. And the window continues, right? It goes from here, and then it goes to here, and then the window grows to here, and then the window grows to here. And if we have more stuff here, then the window then moves to this place, and then it goes to here, and etc. So that's the idea, and let's program it up. All right, let's program this up. So as we said, we're going to need a variable m that stores, the current length, the current number of total outcomes that she could have meant. And we always begin this at 1 because, again, there's the case where she made no intended error. She made no errors, so it's just the original string. So that's m is equal to 1. And we have L is equal to 0 and S is equal to 0. S is the starting position of our window. L is going to be the length of the current consecutive sequence. And with that, or rather, the length of the consecutive sequence minus 1, because that's how we derive the total number of potential outcomes. So now, for e in range of 1 to length word, where e denotes the end position of the window, we're going to do what? There's 2 possible outcomes here. If the current element at s is not equal to the element at the end position, and the other case where it's not, they are equal. So what happens when they're not equal? Well, when they're not equal, then we have to update m by adding it to L, and then S is equal to E, and then L is equal to 0. We reset it because we just finished considering a sequence, and we have to, reset that length of the sequence to 0 because we're considering a new sequence. And we add whatever was there to M, and S gets updated to E to shift the window right. And otherwise, we just do L plus equal to 1. And why is this the case? Well, the idea is that let's say we're considering two words, right? A and B. The starting index points at S and the ending the starting index points at A and the ending index points at B. Then they're obviously not equal. So we enter this if statement. And L is always going to be 0 here. So we add 0 to M and S is equal to E, so we shift it. So we shift the starting position to the right by 1, and L gets equal to 0, set to 0, so we have nothing. And then it exits this body and goes back to the for loop where E is incremented by 1, effectively moving the window right by 1. And otherwise, let's say we're pointing at C and C, then we obviously do not want to touch the starting position, we just want to shift the end position. So we simply update the length by 1 because after this gets executed, we exit the body and go back to the for loop where E gets incremented by 1, effectively growing the window by 1. So that's the whole idea. But we're missing something. Consider the sequence, right? A, B, B, C, 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 C. So obviously the two B's work fine, but what happens for the final four C's? Well, so it's gonna keep incrementing L, but then we're gonna exit the for loop, right? We're never going to actually go into here because these are the last words. Then once the words are done, there's nothing after the last C. So what happens to the L? Well, we have to add whatever's there to M. So we return M plus L. And with that, a small caveat, that should address everything, so let's run it. And it works, so let's submit. And there we go, it passes everything.